Module 5, Section 9.5, Trigonometric Equations and Inequalities, Part 1. First we'll look at solving a trigonometric equation by linear methods. In this example we want to solve 2 sine of x minus 1 equals 0 over the interval 0 to 2 pi. Since this equation involves the first power of sine x, it is linear in sine of x. So we'll set about solving it. First thing we want to do is add 1 to both sides. So we have 2 sine of x equals 1. Then we'll divide by 2. So we have that the sine of x is equal to 1/2, or that x is then equal to the sine inverse of 1/2. So what we can do is, using our calculator, so let's open our calculator, and we want to make sure that we are in radian mode, and we are, and we'll do the sine inverse of 1/2, and here we get our value in radians. Now if we want to find it as a fraction, we'll simply divide by pi on our calculator, and then convert to a fraction. So we see that we have 1/6, and we just add pi back into the numerator, so we have pi over 6 as our answer. Now if we want to do it in degree mode, we'll simply go sine inverse of 1/2 and see that we get 30 degrees, which we can then convert to radians. So we have that x is equal to pi over 6 is one of our values. We're in the interval 0 to 2 pi, and we have that our sine value is a positive 1/2. We know that sine is positive in quadrants 1 and 2. Well, pi over 6 is in quadrant 1. So we want to find our quadrant 2 value. So let's look at our graph here. Pi over 6, which is also 30 degrees, there's our quadrant 1 value. We want to find an equivalent value in quadrant 2, knowing that it's going to have the same reference angle as our original. So pi over 6 here, or 30 degrees, which means to find it we're going to take the value here along our horizontal, which is 180 degrees, and subtract 30 to get 150 degrees, or 5 pi over 6. So there are our two answers for this equation. Now let's look at how we could have solved this using our graphing calculator. And graphing it first, we want to graph y1 equals 2 sine of x minus 1 in our interval 0 to 2 pi. But I'm also going to have you graph y2 equals 0. So we have y1 equals 2 sine of x minus 1, and y1 and y2 will be 0. So we want to graph it on the interval 0 to 2 pi. So let's change our window. We're going to go from 0 to 2 pi, and we'll go at an interval of pi over 2 on our scale, and we'll leave our y values the same. Now let's also make sure we're in radian mode, and we hit graph. If your graph looks funny, if it doesn't look like this, then you may be in degree mode. So our two answers will be here and here. So we want to find them. We'll do second, trace, and then 5 for intersect. And let's hit enter 3 times here. And here's our first value. And then we'll do it again, second, trace, 5. And let's arrow over and hit enter 3 times once we're close to our other value. And there's the other answer. So here we have them on our screen. Our two answers, and if you plug in pi over 6 and 5 pi over 6 into the calculator, you'll see you get the same answer. So that's another way we can solve it. Instead of doing it by hand, you can do it this way. The x-intercepts, in other words, are the answers to our equation. Now let's look at solving the inequalities. We want to solve for x over our interval 0 to 2 pi. So we'll use the graph from before. You see it's the same equation except now we have our inequalities. In part A, we're asked when was our equation greater than 0. So we look at the graph and we see that it's greater than 0 when it's above our x-axis. So that would be between our 2 points here. So the answer would be between pi over 6 and 5 pi over 6 in interval form. And we use parentheses since we don't have an equal to here. If it had been an equal to here, we would use brackets to indicate that we include these two endpoints. Now to do part B, notice that we have our equation is less than 0. It's less than 0 here and here, so we have two places where it's less than 0. So it's between our first point, which was 0, and pi over 6. And we use union to indicate that we have another interval. And we're then going from 5 pi over 6 to 2 pi. Now to know how to label these, notice that still pi over 6 and 5 pi over 6 have parentheses because we don't have the equal to. I put a bracket by the 0 because I have a bracket here in my original interval, and I put a parenthesis by the 2 pi because I had a parenthesis by it. So that's how we can answer our two questions here involving the inequalities. Now let's look at equations that are solvable by factoring. We want to solve tangent squared of x plus tangent of x minus 2 equals 0 over the interval 0 to 2 pi. This equation is quadratic in terms of tangent of x, so we can factor it, and it factors as tangent of x minus 1 times the tangent of x plus 2. And once we've factored it, we set each factor equal to 0 and then solve for tangent of x. So in this first one, we can add 1 to both sides in order to get tangent of x equals 1. And then for our other side, we set it equal to 0, and here we'll subtract 2 from both sides to get the tangent of x is equal to negative 2. Now, take note that the tangent is positive in quadrants 1 and 3, and it's negative in quadrants 2 and 4. So our answers for this first equation will be in quadrants 1 and 3, and our answers for the second one will be in quadrants 2 and 4. So what we want to do here is say that x is equal to the tangent inverse of 1, and in this case x is equal to the tangent inverse of negative 2. When we do the tangent inverse of 1, we'll get a value of pi over 4. This value is in quadrant 1. To find my quadrant 3 value, let's draw our graph, and we see that if here we're at pi over 4 in quadrant 1, to get my equivalent value in my quadrant 3, I simply need to add pi. So I'm going to add pi to pi over 4 in order to get 5 pi over 4 as my second answer. Now we need to use a calculator to find our solution for tan inverse of negative 2, and we'll get a value of approximately negative 1.107, and so on. Now this value is going to be, since we're in radians, this value is in quadrant 4, which we wanted, but it's not in our interval since it's less than 0. So what we need to do is we're going to remember that this is my negative 1.107. I need to find the coterminal angle, so I'm going to have to add 2 pi to it to do that. And then to get my opposite value in quadrant 2, I'm going to have to add pi to it as well. So once we add pi, we'll get the value of 2.034, and we add 2 pi and we get 5.176. So our four solutions are pi over 4, 5 pi over 4, 2.034, and 5.176. Now let's look at solving a trigonometric equation using the quadratic formula. We want to solve cotangent of x times cotangent of x plus 3 equals 1 over the interval 0 to 2 pi. First thing we need to do is rewrite the expression in standard quadratic form, meaning we need to distribute here and move our 1 over, and we'll get cotangent of x, cotangent squared of x, plus 3 cotangent of x minus 1 equals 0. And in this case, a is the coefficient of our squared term, which is 1, b is the coefficient of our middle term, which is 3, and c is our constant term, which is negative 1. Cotangent of x is the variable, so we want to plug those values for a, b, and c into our quadratic formula and work this out. And when we do, we'll get that cotangent of x is equal to negative 3 plus or minus the square root of 13 over 2. Now, when we work this out, we'll do both values, negative 3 plus square root of 13 over 2, to get our positive value here. And we'll do negative 3 minus square root of 13 over 2 to get our negative value here for cotangent of x. Now, since we cannot take the inverse cotangent with the calculator, we use the fact that the cotangent of x is equal to 1 over tangent of x. So what we do is we say that tangent of x is 1 over our value for cotangent. So let me just do one of them so that we see. We originally started with cotangent of x was negative 3.302775638. So let's do 1 over that. And there we get our value of negative 0.302775637. And we do the same thing on the other side. Now we want to take the inverse tangent of that value, and we see that we get negative 0.294, or on the other side 1.277. Now the first of these values is not in the desired interval, so since the period of cotangent is pi, we add pi and 2 pi to it in order to get the following two values. So let me kind of write this out. We know that the cotangent is negative in quadrants 2 and 4. So we see that our value, negative 0.294, is in quadrant 4. So we add 2 pi to get our coterminal angle that's within our 0 to 2 pi interval. And then to get our value in quadrant 2, we'll need to add pi. So here we get our two answers. And now our second value is in the interval, so we add pi to it to get another solution. Because the cotangent is positive in quadrants 1 and 3, so our value of 1.277 is in quadrant 1, so we'll need to add pi to that in order to get our value in quadrant 3. So we get our second answer, which is approximately 4.42. So we have the following solution set. Now let's look at solving this on the calculator. We want to graph it, and we had cotangent of x, or 1 over tangent, multiplied by the cotangent, or 1 over tangent of x, plus 3, and then that was equal to 1. So let's graph over our interval from 0 to 2 pi. And what we want to find is where we're crossing our value of 1 here. So we do second trace 5. And let's go to our starting value here, or the first place where they cross. So we'll hit enter 3 times. And we see here we get our value of 1.28. Let's do it again, second trace 5. But this time, let's switch to our second line here. We want to arrow over and hit enter 3 times. And there you see we get our value of 2.85. Let's do second trace 5. And hit enter 3 times once we're close. So we get our value of 4.42. And then our last value, second trace 5, we'll arrow over, and let me arrow up to it so that I'm on the Y2 so I can see it as I go. We'll hit enter 3 times. And we get our final value of 5.99. Now let's solve a trigonometric equation by squaring and trigonometric substitution. We want to solve the tangent of x plus the square root of 3 equals secant of x over our interval from 0 to 2 pi. First, we'll square both sides in order to eliminate our square root of 3 and use our identity 1 plus tangent squared of x equals secant squared, one of our Pythagorean identities. So here we've squared this side, meaning we've taken tangent of x plus square root of 3 and squared it, which means we can simply write it twice. And FOIL, and when we do, we'll get tangent squared of x plus the square root of 3 times tangent of x plus the square root of 3 times tangent of x plus 3. So we end up with 2 square root of 3 tangent of x's here. And then our other side will simply be secant squared of x. Now what we want to do is use our identity and plug in 1 plus tangent squared of x in place of secant squared here. So that's this next step. And what we do is we'll subtract the tangent squared of x from both sides to eliminate it here. And then we'll subtract 3 to get negative 2 on this side. Now we'll simply divide by 2 square root of 3, and we end up with tangent of x is equal to negative 1 over square root of 3, or when we rationalize it, negative square root of 3 over 3. So our possible solutions are 5 pi over 6 and 11 pi over 6. And we'll verify that the only solution is 11 pi over 6. So to do that, first let's show where we've come up with our answer. We'll take the tangent inverse of a negative square root of 3 over 3. And then we want to divide by pi and change that. So we get negative pi over 6 which is in quadrant 4. And we know that the tangent is going to be negative in quadrants 2 and 4. So in order to get our value within our interval, we'll add 2 pi to negative pi over 6 to get our 11 pi over 6 answer. And then to get the value that's going to be in quadrant 2, we'll simply add pi to negative pi over 6 to get 5 pi over 6. Now to verify our answers, which we have to do whenever you square, we want to plug in to our original equation. So we have the tangent of x, so we'll do tangent of 5 pi over 6 plus the square root of 3. And we want to show that that's equal to the secant of x, which would be 1 over the cosine of 5 pi over 6. So we see that we get the same answer, but one's positive and one's negative. So 5 pi over 6 is not a solution. Let's do the same thing, except that now we're going to change from 5 pi over 6 to 11 pi over 6. And we want our answer for 1 over cosine, but now we want to use 11 pi over 6. And we see that this time we get the exact same answer. So 5 pi over 6 didn't work, and we verified that 11 pi over 6 is the only answer. Now let me show you how we could do that on our graph without having to do it by hand. We'll clear out both, and we'll put the tangent of x plus the square root of 3, and then for secant we'll do 1 over the cosine of x and graph. And we see that this point here is the only place where our two graphs will cross each other. So we do secant trace 5 and arrow over to our place where we're crossing, and we'll hit enter 3 times. And we see that here we get 5.76. Let's clear our screen, and remember we can find what it is in fraction form by simply dividing by pi and changing to a fraction, and then adding pi back into our numerator, so we see that our answer was only 11 pi over 6. Our steps that we use to solve a trig equation analytically: first, we decide whether the equation is linear or quadratic, so you can determine the solution method. Second, if only one trig function is present, first solve the equation for that function. 3, if more than one trig function is present, rearrange the equation so that one side equals 0. Then try to factor and set each factor equal to 0 to solve. 4, if the equation is quadratic in form but not factorable, use the quadratic formula and check that solutions are in the desired interval. 5, try using identities to change the form of the equation. It may be helpful to square each side of the equation first. If this is done, check for extraneous values. And always remember that you can also solve using the graphing calculator the way I've shown.